Okay, good morning. I hope you can all hear me. My name is Cindy Casey, and I'm going to get started because I want to make sure we have time to go through everything and that there's some time at the end for questions. And I'm going to be presenting today on web vulnerabilities, and so we're going to just get started. So the question is, why web vulnerabilities when there's so many really exciting things to talk about in cybersecurity and security today? And so I'm going to give you a couple of reasons why I decided that it would be a good idea to do a talk on web vulnerabilities. And the first one is because 30,000 new websites are hacked every day. And also, um, data and studies indicate that the average so data indicates that the average broadband internet user in the United States surfs approximately 138 pages per day. And of course, that's not counting Wi-Fi users and users that are accessing the internet via their tablets or their cell phones. And most people do access with their cell phones. So that's another reason. There are over 175 billion websites. Of course, people are still using weak passwords, and I know that no matter how much people talk about this, we still see that people are doing this. They're not treating their passwords like you would your toothbrush, as the old saying goes. So choose a good one, change it regularly, and don't share it. But weak passwords, 85% of Americans, study by Avast Security shows 85% of Americans are still using weak passwords that include their name, address, pet's name, and believe it or not, 1, 2, 3, 4, 5, followed by the much more secure 1, 2, 3, 4, 5, 6, 7, 8. So that's one of the reasons. And also, the coronavirus, COVID-19, has had an impact on web security as well. With 42% of the U.S. labor force working from home, this is really actually, there's like an increase now in web attacks. So interestingly, more than 50% are using their personal computers to work from home, so approximately 53%. And that's interesting. That's both Kaspersky Labs and the Stanford Institute for Economic Policy have done studies on this. And just to think of how insecure it is to have workers from home using their own computers. And so there has been a surge in cybersecurity breaches since people have began working from home with the COVID. So there's a real need to educate and protect remote employees from web-based cyber attacks. So this is another reason that I decided that web security would be a good talk for today. And then I know that I'm sure some of you probably follow Verizon's data breach investigations report that comes out every year, and it's filled with some, shows you the trends in cybersecurity attacks, what's being attacked, methods that are being used. And according to the latest investigation report, the 2020 report, 43% of all breaches analyzed that they analyze use some form of web application attack or breach. And they see an increase as well. And so the attacks on web applications actually began surging before 2019, but there has been an upward trend. So for people that follow the Verizon breach report and other reports that come out yearly, they have seen this increase in web-based attacks. So in the web application statistics, in these types of attacks, and a web application is just like software that runs on a web server rather than on an operating system. So this is the breakdown, basically, and this is from Malware News, of what types, because there's many, many, many types of web application or web. I'm just going to say website, and that means application as well. So of website statistics attacks. So the ones we're going to talk about today are cross-site scripting, SQL injection, and we can see that these are the most popular, as represented there in the circle, 39.1% and 24.9%. We're going to talk about path traversal, denial of service, which a lot of people think about when they're thinking about their servers getting hacked from the network, but they might not really equate it so much with web page attacks or web application attacks. And then also some of the other types of attacks, because they're not all as complicated, not that cross-site scripting or SQL are that complex, but they're not, some of the attacks are so simple and that people actually stumble across them by accident. And I've seen this, and we'll talk about that a little bit as well. So I'm going to start with cross-site scripting, which interestingly used to be called the same initials as cascading style sheets, CSS, and then they changed it to XSS because there was some confusion. But it's a client-side code injection attack, where the attacker like executes a malicious script into a website or a web application, and the attacker is not targeting the victim directly, but actually is exploiting like some kind of vulnerability in the website that the victim visits. So cross-site scripting works by like manipulating the some vulnerability in a website, so it returns a malicious JavaScript script to users. And so the target is the user of the website, not the website. So with cross-site scripting, the target is actually the user. And the technique actually began when JavaScript came on the scene. So it's been around for a long time. It's an older type of attack, but it has never lost popularity. In fact, as the internet grows and users grow, so does cross-site scripting. So there's three main categories of cross-site scripting. So I just want to give you a little bit of information on those so that you can tell the difference between them. And the first one is the stored. Actually, I'm going to start with reflected, even though I have stored first on my PowerPoint. But the reflected, it's malicious input that originates from the victim's request, but it's basically from the victim maybe clicking on a link, right? So something, a URL, like a malicious script will bounce off of another website to the victim's browser. So it's passed through the query, through the victim. And typically URL or clicking on some type of link will actually, is how that attack happens. Now with the stored, which I have at the top of the list here, the malicious input originates from the website's database. So a script is submitted like via some kind of input field on a web server, and infects the web server, which in turn will store the script in the database, in the web server's database. So any user coming along visiting the server or the database will retrieve the script while they're actually accessing information. So that's the difference between the two. And then the third one, the DOM-based or DOM cross-site scripting. It's a vulnerability. It's in the client-side code rather than the server-side code. This is the most complex. The attacker actually embeds a malicious code in the URL. The browser parses the HTML page, reaches the script, and runs it, and extracts the malicious content. So this is a little bit more difficult. And here I have a little example to kind of give you a little visual of what I'm talking about. So here we see the hacker, and the hacker has some type of script that he's going to inject into some company's web page. Right? So the script is injected into the web page, not into the victim, into the web page. The victim comes along. I have little circles here. And the victim comes along and visits the web page, right? And the script is injected into their browser. So now this script that's in the victim's browser can go do something else somewhere else. It can do some nasty somewhere else. It might have taken some credentials and do whatever the hacker wants it to do. It could also report some information back to the hacker itself. So this is what I mean by it's not a direct attack into the victim, right? So it comes from the browser. And then here's a little example. I have here a little comment type form, and you've probably seen these. I know social media uses them, a lot of blogs use them. A lot of company websites have these types of forms. Some of them are, email forms like contacts, so and so and whatnot. So this is kind of like, right, baby's first script. This is what you do in your first programming class. So you have this little script, and I'm just using this as an example, right, which usually says hello world, something pops up. But what if it was some nasty malware, right? What if there was some nasty malware in there? So some of the things you want to do is you don't want to accept anything from unknown users. That's the first thing. If you're going to accept links, which I probably would not, but if you're going to accept them, if that's part of what you need to do, then you want to check the URLs before you actually trust them. So you want to, anything that's untrusted, you want to check. You want to assume everything is malicious. That's what untrusted data is. Anything that originates outside of the system that you don't have absolute control over, right? That's untrusted. That's all untrusted. Validate, and then validate again. Sanitize the data. And try to get rid of dangerous characters. Don't make it so easy for the hacker. And this is just an example, right? So instead of using some of these characters, switch it around a little bit. It'll still work, but it might be a little more work for whoever's doing your coding. It's definitely worth it. So sometimes you really just have to go through it a lot. And there's a huge number of vectors in cross-site scripting. There's a lot of things they can do. So, you're never, I use the word deter instead of prevent, because I always have an issue when somebody says we're going to prevent it, because you're really deterring it, because you're never going to get rid of all attacks. So what you want to do is try to deter it. You don't want to be the low-hanging fruit, and you want to be aware of what's going on. So that's what you're trying to do. So I'm going to move on now to SQL, to structured query language, SQL injection. And here, this allows an attacker to interfere with the queries in the database that it makes, the queries an application would make to the database. So it basically lets the attacker view data that is normally not able to retrieve. They should not be able to retrieve. And if successful, a SQL injection can result in unauthorized access to sensitive data, passwords, credit cards. So it's really a dangerous type of attack. And in the little graphic I have there, you can see there's an attacker, and he changed some code there, right? And ended up returning all the students. I'm going to show you a little more how that works. I believe it's on the next slide. But basically, you'll see at the end, after the 1 = 1s, which is true, right? That's why we use the 1s. But you'll see the little dashes, the little slashes. And that basically is just saying remove the password check, from the where clause. So, and I'll show that a little bit more. So here's my example that I wanted to kind of show you. So if I have this I think will explain it better. So if I have this form here, and I'm going to put in the user ID and a password, that's what you see on the user end. But on the back end, what the database is saying, right, select, and of course the little asterisk or star just means all details, from users where the user ID is Casey and the password is my password. And of course you would never have a password that bad, I'm assuming. Now let me not assume that. So, and this is what somebody that's doing a SQL injection could do, right? So the 1 equals, basically it evaluates to a constant true. So it's going to return all the rows in the table. And of course, the two dashes that I was the double dash just means that the rest of the query is interpreted as a comment. So it removes all the remainder stuff and it just displays everything. And 1 equals true. If that was a 0, then it would be false. So basically what's going to happen here, if I'm explaining this, I hope correct, so you can understand me. But what's going to happen here is the hacker is then going to select all users and all their passwords. That's what's going to be returned. So that's basically how a SQL injection can be performed. And it's not that difficult. There's also tools online. I know Kali Linux has have it. I don't know if it's still in there, but you can download it for free. And the tool, in fact, there's a video on YouTube that's pretty interesting. It's called SQL Injection So Easy. A 3-year-old can do it. And what's happening is in the video, the gentleman actually has his 3-year-old child running the tool. That's how easy it is. And it will extract everything out of the database. So he extracts all the passwords, the emails, the user accounts, and so forth. So then the differences between the two, if we're going to talk about the differences between SQL injection and cross-site scripting, just so you get a better idea of what I'm talking about, is with the SQL injection, right? The insertion of the assertion of a SQL query via some input, right? Some data, some form, some application. It's parsed to the SQL server, and then there's an execution. So it puts the server side at risk, right? Where the cross-site scripting enables the attacker to inject client-side, some kind of JavaScript client-side script, or HTML markup into web pages. The code's not permanent. Now, I know we talked about stored cross-site scripting where it goes into the server, but it's not permanent the way that SQL injection is. So it's a little more difficult to track, but not impossible. And it puts the client-side data at risk. So more so than the company data. So that's the main differences. It really shouldn't work. SQL injection should not work in theory if you're sanitizing your data and you're making sure that you're not enabling characters. For instance, when you teach an initial database class, you'll teach students, well, you only allow so many characters in the field for last name. Well, then the answer is, well, like we can't fit all the last names now. Like, well, if you want to make it bigger, do you want to make it larger so that more code can come in there? So just the basics from beginning database. For those that are in education, when you start teaching database, that's where it begins. The same with the web design, right? When you start teaching things like JavaScript and PHP, that's where it begins. So you have to really be familiar with your code when you're coding and try to make sure that you check and double check, right? Not just once, but twice, and make sure that people can't exploit what your code. So moving along to the denial of service attack, which is probably one of the popular ones. It's used to tie up the resources of a website. So here I have my little picture, right? Where, and you can run a tool that does this. It's not like it's complicated. So I'm going to tie up I'm going to make 100 requests, thousands of requests to one web page. It's going to bring the web page down. So, and that's basically what it's to do. It's to use up the resources so that legitimate users who need to access the site are unable to do so. So we can imagine how much damage, for instance, you could do to Amazon if you took their web pages down. Of course, I'm sure they have backup, but let's assume they don't. And you take their web page down for even, we'll say 20 minutes on, how about Black Friday when everybody's out shopping, day after Thanksgiving. Could do a lot of damage to a company. And also to an organization whose employees need to access the website. So the attacker just basically generates some large volume of packet, some kind of request, and it just overwhelms the target system. And that's the denial of service attack, which a lot of people don't think so much. They don't include that in when you're talking about web attacks, but this is one of them. Then there's the distributed denial of service attack, right? And if we can just assume that each of these computers is 10,000 compromised machines, the distributed denial of service attack is exactly that. It's very difficult to trace because you would have a hacker who would take control of some command and control. They'll call command and control. So they'll take control of a couple of servers, number of servers. Through those servers, they'll take control of, they call them zombies or slaves, some more computers, and then through them, they'll take some more. And I think you can kind of look at the visual and get an idea how many layers this could go. And this would create a botnet, right? A little army of available machines that at any given time, the person at the top, the hacker or the master, the person that's in charge, can give a command, and all at once, all these machines would make a request of some service somewhere. And it would literally take the service down because the machine would be overwhelmed. It would not be able to handle it. And what's interesting is, it doesn't have to be computers. Think of all the Internet of Things. There was actually once where a bunch of refrigerators took something down. Read that in the news. So it doesn't have to be computers or servers. It can be lots of different things. So keep that in mind when you're trying to secure stuff, that you're not always looking for computers. Now, I wanted to talk a little bit about scraping attacks because I don't usually see a lot on that. But the web scraping, it's basically extracting data, underlining HTML code, and with it all the data that's stored. And the last example I can think of it is I just worked on a site with 2 students where we wanted to take all of the courses that were offered from 8 different universities and pull them into one web page so that you could just look for the courses. So I could maybe say, I need an online course in math. So you pump that in there and, all the math courses come up and it gives you real time, seats available, time, who's teaching it, and whatnot. So that's an example of just web scraping. But if you're looking for code that you shouldn't have, right, then that would be an example of a legitimate use. In fact, you'll see it in price comparison, market research. But the illegitimate use, like undercutting prices, theft, copyright material, duplicating, you can totally replicate an entire website. You scrape all the data and then you could set it up somewhere else, right? And if basically like a legitimate use of this, you could have, you could put the robot text file inside your, web page, your website, and like the malicious scrapers won't touch it, right? But however, the the malicious scrapers, well, don't listen to that. They don't abide by that. So it's considered malicious when the data is extracted without permission of the website owner. And that's basically the bottom of it. And this is becoming really popular. I know that you could do that, write a little script in Python or whatever and start extracting data. And web harvesting is really, it's done all the time. It's done for business, a lot of different, like burning glass software, people are doing it. They'll go out and scrape all the websites, like the job listings, put it all together, and then charge somebody a lot of money to get the information. So, just wanted to throw that in there. Then I wanted to give an example of the difference between the web crawling and the web scraping when we talk about data harvesting. So, in the left where you see the web crawling, it's an example of a robot's text that would be put on there. Of course, if it's Google, you have to do Googlebot text that's put in there. And the user agent and to disallow. So basically what you're saying is don't take any links from here. Because what happens is there's software that goes out. Sometimes it's called a spider. And it goes out and it goes and extracts links. It goes from link to link to link. So it goes through a link, through another link, through another link. And this goes on all the time. And all this information, I'm going to use Google as an example, but it's not just Google. So all this information is gathered up, indexed, and stored in Google's database. So now you come along and you go to Google and you punch something in. I'm going to do a search. And they have all these links and all this information. It's all been indexed, right? But it's not just Google that does it. I know, for instance, Disney does it. companies do it to make sure that their information and their name and their employees are not disclosing something. So they actually are doing this technique too. So when you web crawl, you're gathering this information, you're storing it in a database. If somebody is telling, saying, hey, like I don't allow this, I don't want this to happen, and they put the robot's text in, their page is supposed to be respected, and that's the end of it. And the spider or the technology, the software will just go right past there. But with web scraping, you can ignore that. And they go out and people will scrape everything, right? For whatever reason. When we're talking about hackers here or attackers, and they'll just scrape everything, all the information and everything they can get. So that's basically what happens with the web scraping. So that would be the difference. Just ignores the robot. And another one, and this is not, right? You don't need a script for this. This is not so difficult. Is the Typo Squad, right? Where the hijackers will register misspelled versions of your domain so that they can send traffic to malicious sites. Now, of course, this to me seems like a much more difficult and expensive way and an easier way to get caught if you were a hacker. Not that I am, but if you were, this seems like a little bit more, more money when you could just do some other kind of script and redirect the traffic. But people do it. And then they might register all possible versions of your domain. And so when people will make mistakes and they get to your domain, or they can use this when they're sending you phishing in the email and you might not notice. So my top example is gmercyu. Well, in my example of what Typo Squad, I took out the U. So that could come, and we're all taught, don't click on links, hover over it and see where it goes. I could hover over that. That'll appear in the corner, and I might just totally miss that and think it's legit. And my second example is the Amazon, right, where I replaced the O with an A. If you're hovering over a link in your email, it would be really easy when you're looking at that bottom to see what's popping up when you hover over it to miss something like that. And so I have a couple other examples there. And you can see in the PFCU loans, I just added an underscore, right? So, you could just change things around. In the Beatles Club, I added org instead of com. You might miss. These are things that people would miss. And we're not just talking about people okay, everybody here is here for a reason. Either you're a student or you're a professional and you're trying to be educated in this. But the average user, all the employees and everybody else, they have to be trained on this. They're not just going to know this automatically. So definitely, it's something to think about because it's an easy thing to do, and people don't really think of this when they're thinking about securing their web. They do think of the original attacks, the ones that have been around forever that I talked about, the cross-site scripting, SQL injection. They're the ones everybody concentrates on, but they forget some of these smaller things that can be, have devastating results as well. Now, the redirection, the URL redirection, it brings the browser from one URL right to another. And malicious redirects are caused by hackers injecting scripts into infected sites. And it just sends the visitors to a destination where they usually get scammed or infected with some more malware. And these are really pretty common. And one of the easiest ways, the simplest ways, and there's so many ways to do this, but one of the easiest ones is just the HTML meta tag way. You can also do JavaScript redirects where you change the location. So it'd be like window.location equal, and then whatever the website is. Of course, there's multiple ways to do that too. So it could be window.location.replace. So that's a whole lot. And also Apache Redirects with 301. So there's more than one way, but I'm just picking the easy HTML because a lot of people are familiar with this. So here we see the meta tag HTTP, right, to refresh and to direct somewhere else, right? But I could do this, right? I could direct it to an evil website. And that quickly whoever the visitors are, they're just redirected. So they come to my site, which I might have scraped your site. So my site is identical to your site. I didn't even have to build it too much. I didn't have to sit there and replicate it bit by bit. I just took your site, set it up in mine. So now the users will come to me and hopefully log in and I'll get all their information. And so that's basically the little sample of redirect. Now the path traversal is a little bit, this is much more difficult. It's also called a directory traversal. It allows the attacker to access the files, directories, and commands that reside outside of the web document. Basically, they're trying to get to root, which is, think of admin, you'll think of root. So any device that exposes HTTP-based interface is potentially vulnerable to this. And you'll usually see like the .. notation where, it basically, each one is like going up a layer or like a directory or a folder. Instructs the system to go up on a directory or folder, like go up one. So if you see one ... you see two, you see three, that's how high they're trying to get up. And of course, etc. password is just going to take them so that they can get all the passwords. But basically, the attacker just manipulates the URL in a way just so that website will, reveal the contents or arbitrary files anywhere in the web server. So it allows hackers to access restricted directories. They can execute commands. I mean, imagine if they get in there and they just decide, I'm just going to drop tables, drop database, or whatever they decide to do. They might take your information, drop it. They might actually take your stuff. And this, we talk a lot about ransomware, and these are some of the techniques that are used where they can actually do that. To get all your data, tie you up. You won't be able to get into it unless you pay some kind of a fee. So the URL hacking or do-it-yourself navigation, it's kind of a little fun. So with this technique, it's just where you change. It's moving through a website by playing with it directly. So you simply like lop off the end of an address, change something in the URL. That's like called prediction. And just because a website permits a hack, just so you know, it doesn't mean that you can do it. You shouldn't. Let me rephrase this. Anything that you are being told right now, right, is not something you can just go out and do on people's websites. So you can't just go online and start doing this. Similar to like the Google Dorks. I don't know if anybody's familiar with the Google Dorks, which is where you can actually, some advanced search features you can use in Google, and you can get access to like people's databases and all kinds of things that you're not meant to get access to. But I can tell you from personal experience, if you do it, the first time Google will suspend you for like an hour or two. If you do it like a second time, they'll extend you longer. If you do it 3 times, you lose your Google privileges for a couple of days. And if you've ever tried to live without Google, it's kind of difficult. So my advice is don't mess around with this too much. But basically, you can change something and end up in the parent directory and have access to all kinds of files. And I've seen this a lot where, like, it might be a site like maybe an instructor has stored a lot of work, not in any of the universities in our region, right, because we're on top of that. But I have seen where a university will have all their information. The instructor might have all their lessons and tests and things stored. And then you just lop something off the back and you're in their directory and you can get access to all their lesson plans and their recordings and all kinds of things like that. So that's something you want to watch out for. And this little example I want to show you because it's not just websites. Now this was from, it's not from anybody you know. But this was just an example of where, and this was actually, I was teaching someplace at one time, and a student actually brought it to me. And by the way, this breach has been fixed in a learning management system, we'll say. And so a student came and said, oh, look, Miss Casey, I changed this number, and look, I'm in here, and I got all this information. They had access to everything in another school within the university. So, yeah. And in this one, you could just this was just changing a course number to a different course number. And it actually, the black boxes are to protect the place that it was. Because I, of course, took screenshots of it. That's something I do. So it just basically, it took you into another directory, another course where you had access to all those students. You had access to all the information, all the tests, everything that was in that course that was for that student. But other students could do this. So it wasn't, you know, I later learned that you could also do this in higher functions that students didn't have access to, but it was just an example. And I'm just using it as an example of how you can change something or lop something off or do something where you're going to have access to something that you're not supposed to have access to. So that's just another example. And I don't know if anybody's ever done it where you got a free copy of a chapter, a PDF copy of a chapter. And so it might say chapter 1, but you're really into it. You want to see the rest. So you'll chop off chapter 1 and turn it into chapter 2 and see if you can open up chapter 2. Or lop off all the chapters and you go back to like where all the chapters are stored. I guess we'll see. So now I'm going to talk a little bit about the remote file inclusion. And remote file inclusion or local file inclusion, they're just vulnerabilities found in poorly written web applications. So they occur when a web application allows a user to submit input into files or uploads to the server. And in the graphic I made, you can see that there's an attacker, and the attacker targets some vulnerable code, instructing the server via the web browser to include some file or put it into the attacker's, to prepare it, send it for the attacker server. So the script is included, executed, and basically what the attacker is doing, then he's creating a backdoor so he has access in and out of that site. So that's what's happening there. I'm trying to keep an eye on our time as well. So I want to talk a little bit about deterrent attacks, and these are a few of the things I want to talk about: patching and hardening, application profiling, protecting pages, IP whitelisting, bad bot blocking, signature detection, geo blocking, machine learning, and there's a lot of stuff happening with artificial intelligence and machine learning, and avoiding file uploads. So with protecting pages, the first, did I skip something? No. Okay. So with protecting pages, you want to hide the admin pages. You want to use the robot.txt or google.txt, even though you know that can be ignored. But you want to try to do that. You want to try to avoid search engine indexing on certain pages. You want to use encrypted SSL protocols when transferring personal information between a website and the database. And you want to just tighten up your access control. Now, with the IP whitelisting, you basically want to just only grant approved programs and approved IP addresses and email addresses system access. In other words, whatever's not on the list is blocked. But these are not one size fit all. The admin will determine what they are. And they're not always guaranteed, right? Because somebody can, of course, change an IP address or whatnot. So spoof an IP address and so forth. And patching and hardening, and we see all the time, at least I see all the time, where people will not update, big fool. You want to do all your hardening your system. You want to, rule number 1 is keep up with your updates, because they're usually being sent out because the software or the company, the organization found some kind of hole or vulnerability, and they're sending up this update so you can, secure it. And so people let that go. And of course, hackers look for that. They look for stuff that hasn't been patched or upgraded. An example of that is if a hacker will go into Shodan search engine and they'll start looking for all the older versions of stuff, and you wouldn't believe how old some of the stuff is. And they know that's the stuff that's easy to target. They know that, sorry, my phone should not have rung. So they know that's the stuff that's easy to target. and they're going to go after it. And unfortunately, that's a lot of websites because people put their websites up. They do a little bit of tweaking here and there, but they really do not upgrade, harden them, and change things like they should. So we don't just put something up and leave it alone, right? And then application profiling is just blocking requests that don't fit the web application's profile. So you just inspect the requests and look for anything that's abnormal. And that's basically what you do there. Bad bot blocking. Block or use the CAPTCHA. Outdated browsers. Investigate traffic spikes. Define your failed login attempts. And baseline. And then monitor for abnormalities. You should always have a baseline. Monitor your traffic sources carefully. One of the best things to do with this is actually look at the packets, see what's happening. I know Wireshark's a great tool for that. Then Geo Blocking is just block websites from users from specific areas. However, once again, so you might say, well, I don't want anybody from China, so I'm going to block that. Anything from that block of IP addresses. The problem is, it can be bypassed. They can use VPN, Tor browsing, proxy servers, spoofed IP addresses. So it's not really a guarantee that somebody's not going to get into your site. So here's just some information on because I have mentioned it. The CAPTCHA, which is just basically the completely automated public Turing test to tell computers and humans apart. So it's basically to prevent website failures, to prevent attacks. So, you can't use a machine to kind of do this, or so they say. And it was it's first invented in 1997, although I don't think it even emerged until like early 2000. But it's just a challenge response, right? To make sure that you're a human, and this is not some bot, right? This is not some software program or some army of computers that are trying to get in and do something. So let's just check, and we'll make sure that you're actually a human. And then they updated it, right? The free service from Google to help kind of protect you from spam and abuse. So they actually added something more to it to make it a little more difficult for a computer. And the reason they had to change it is because computers figured out how to do it the other way, or I should say hackers. So it prompts the user to confirm that they aren't robots by asking them to read this distorted text and type it into the box. And they also gave you the option now. It's a little updated of a sound for people that had problems reading for different reasons. I know that I always have a hard time with them. And then the newer one, which is the no captcha, reCAPTCHA, which is basically at the end you'll see I'm not a robot. And it doesn't just rely on the user's ability to decipher some text, but actually on their behavior prior to the security checkpoint. So while the user's on the page, an invisible algorithm is monitoring how they interact with the content to determine if they're really a human or a robot. And you see the little things pop up like check all crosswalks, check all buses, the little, so they can check out who you are. But these are going to be hacked, and basically this is one of the examples where artificial intelligence is going to come in. So that's going to be, you're going to see that stuff fading out. And cyber criminals have already even started putting these on their own sites, on fraudulent websites, because it makes their scams more believable. So if you go to the site and you have to do this, I got to make sure they know I'm not a machine. There you go. You're falling for it. And because I mentioned AI, I wanted to include some type of AI web attack, and this was one of them. This was one of the artificial intelligence web attacks. And I don't know if anybody here has ever used TaskRabbit. When they first came out, I'm not going to lie, I used them. I had some brick stuff I had to do around the side of the house, and I couldn't handle it. So it's just an online freelance labor marketplace. So it's basically, you put in a job, you find people, you pick the person you want, they come out, they do it. But this was hacked, and all the username, passwords, bank accounts, social security numbers of 3.75 million users. That's a lot of people were hacked. And it was so severe, and you can see a little message on the right, they actually had to shut down until they could figure out what to do. And it was a distributed denial service by a massive artificial intelligence botnet. And it got all this information just boom. So you're going to be seeing a lot more of this, and these are going to be difficult to fight. Not impossible. And of course, application profile, you want to block requests that don't fit the web application's profile. So your web application firewall, inspect requests and responses. Search for anything that's abnormal. Of course, if you have a baseline, you'll be able to recognize it. If you don't have a baseline, you might not. So it's another reason to always have that good baseline. Even for web pages and web applications, make sure you have them. And I think this was kind of neat, so I just threw this in here. There's a little safe browsing site status that you can actually check. So if you're out there and you're like, I don't know if I want to go into this page, I'm not sure, you can actually check it and make sure it's safe. And people put their own stuff in there too, but just, be careful because everything that you give to Google, right, it's all going into their AI database and information. And there's a link, but I believe that the slides are going to be shared. I know they typically are, so you'd be able to get that link. And then the other thing I wanted to show you is to show you that it's not all as hard as it might seem. It's really not. So there's a lot of sites out there where you can practice hacking. And I just wanted to show you how when you have bad code or when you don't take any precautions or update anything, how bad it could be. So here's a site, and we have to enter a password to continue. So it's like, well, I don't know the password, so what do I do? Right? So I just right-click anywhere on the page, view the source, right? And so now I'm into the page. Now I just have to look for the password. There it goes. So then I would get into that site and move on to the next level, which I thought I had a screenshot of, but I don't. And of course, some of them used to right block it so you couldn't get in. So you just hit Control U and you're in. And of course, the more complicated ones, you have to look at the JavaScript and whatnot, but that's for another time. So some of the browser-based attacks that you can attack, and this is one of the things that drive me nuts when people store all their passwords and things in their browser. Browser-based attack. You get a hold of somebody's browser, you can get all kinds of information. The cache and so forth. And I'm trying to move it along here before I run out of time. But, back in for fresh attacks, password, everything that's in the browser, autocomplete stuff, browser history. So if you look at somebody's browser, a wealth of information. And I wanted to throw this one in here, this Rig exploit, because it spreads via advertisements that are inserted into legitimate websites. So somebody has this in there, and it combines a combination of technologies like web technologies. And what it does is it actually changes and encrypts the files and puts multiple instances of the malware on your machine. So even if your antivirus or your methods of hunting things out, I hope you don't just rely on antivirus malware. But even if that doesn't find it. I mean, if it finds one instance of it, there's backup. So this is a kit, right? An exploit kit, a web exploit kit that has backups and encrypts and dynamically changes its coding so that you can't find it. And it looks for, once again, update your stuff. It scans your browser for security holes, particularly outdated software. So you want to make sure you don't keep saying dismiss to those Flash and Java and Adobe updates, right? And then to end this all down, I threw a couple things in here I thought you might be interested in. And the first one is the Open Web Application Security Project, one of the best and only best places to go. It's nonprofit. It'll include tools, resources, a free proxy tool called Zap. It has education and training. On the right, you see a little screenshot that shows the tutorials, basic level up to advanced. A lot of fun, great stuff. You should include that in any of your training. And it also has the web security test guide to help you make sure that your sites, and I don't work for them, even though I sound like it. And then Hacksplaining is a fun site where you can go and actually click on a different attack, and it'll actually give you examples. It shows you the code, it shows you how it's done, it walks you through it, and then it even has quizzes to see if you're learning it. I kept on time. Thank you very much. Is there any questions?
Cindy, what do you recommend for, I'm thinking about the last presentation as well as this one. Hey, here are how bad guys get through the web. And the first recommendation of you need to make sure your posture is strong. Do you guys do like yearly tests every other year? What do you recommend, or what do you even see as common in kind of the education space?
Well, it depends on how large the company is. I right now I'm in education, so I'm not working with companies, but I would suggest more than yearly. I would suggest at least twice a year, but it depends on the company and everything you're using. What kind of what kind of technology you're using. So I don't know if that helps any. But
yeah,
I think
well, I mean, in particular in the education, as well, colleges and universities.
Okay, so you mean to teach or to actually test or?
Yeah, I guess I was saying, the testing component, not just for organizations or private companies, but schools. If you would say, hey, probably the same thing, once a year, twice a year.
Yeah, I would. And with schools, really keep a track, especially some of these these learning management systems that are supposed to be so secure. Every time you go into them, you can find things that are not secure, which then, of course, violates FERPA and everything else. So, somebody gets a hold of that because you're in education. So definitely, don't just check, here's the school database, here's the website, we're going to do this, we're going to do that, we got our firewall up. Because the other thing I found at one place was, and I think I talked about it last year at this event, RAM malware that was actually came through the routers. So, yeah, definitely keep a check on that. And if you're in security, it's great stuff to just get material for your class. I mean, you don't want to tell them, hey, go here, but
sure. Yeah, that's helpful. Thanks.
Are there any other questions, or did I rush through too fast? I still had time. I was trying to hurry. I had a lot of stuff there. I was getting stumbled up. But it is, it's fun. I think that it all starts too with the students and the training. You have to let them know from the beginning what the vulnerabilities are and how to go over their code and check it and then check it again, and to try to work in ways that they can't to make their sites secure. So there's no, that's one of the things. And I know my favorite thing is looking for looking for the stuff that's not secure. That's my favorite thing in the world. So that's what I like doing. And it can be fun. So it can even be a whole class lesson if you can find something online. Not illegally get into it, but you can always view source and have students look at the pages and find the errors or the things that they would change. It'd be good training too. So it's just one of them things.
Sure.
Well, Cindy, thank you for your presentation. We have to move on because we got our 10:30. Let's see where we at now. Yeah, our 10:30 presentations will be starting shortly.
Okay.
And thank you for presenting today. Hope everyone got a wealth of information out of this, and all the presentations are recording, and we will be posting links to anyone who missed a presentation or had a presentation running in another session that they wanted to view, they'll all be available to everyone who has attended today.